All right, so now we're looking at some examples and trying to determine if they're functions, and then if they are functions, looking at domain, codomain, and range. So for this first one, I see that every element maps to one element. It's okay that 0 maps to 0 and -3 maps to 0. That's fine as long as 0 maps to only one element and -3 maps to only one element. So yes, this is a function. My domain, I'm going to list in ascending order, just out of convention. No, you could list it -3, 0, 3, 0, -3, but convention says we list it in ascending order. Every element here is used, so that means the codomain is equal to the range, -1, 0, 2. All right, over here, straight away I see that 5 maps to both 2 and 9. So 5 does not map to a unique element. This is not a function. It could be a relation, but it is not a function. All right? Every value is used. Every value has a single line coming out of it. I see here my codomain and domain are different though. So domain is going to be the values from 1 to 5. My codomain is going to be the even values from 2 to 14. So at least 3 to establish a pattern. You could also write this as 2n, where n is an element from 1 to 7. So let's see what that would look like. We could say 2n, where 1 less than or equal to n less than or equal to 7. N is an element of integers. It's a little bit more unwieldy than this, but either one is okay. And our range here is the values that we've used, so just 2, 4, and 10. All right, continuing on. So now we have a relation R on Z, such that A is related to B, where A squared is equal to B squared. Well, I know if A squared is equal to B squared, we could have values of, so pairs that would work here are 1, 1, or -1, 1. Yeah. This is okay, this works, but I could also have 1, -1. So now I've got elements from my domain that do not have unique outputs, so not a function. Okay, now R on the positive real numbers. A squared is equal to B squared minus 1. So let's look at a proof by contradiction. So let's say that this is not a function. So suppose is not a function. Okay, so if R is not a function, that would mean for an individual A, I would have 2 different outputs of B. So we could say that A is related to B. That's going to imply that A squared is B squared minus 1. And A is also related to C. Yeah, so if it's not a function, both of these would be true. A squared is C squared minus 1. Putting this together, 0 is B squared minus C squared. This implies, of course, that B squared equals C squared. And B is equal to C, since we're looking on positive reals. So now we don't have negatives. But if B is equal to C, that means for each A, we have only one output. So for A, there are unique outputs. So it must be a function. So we have contradicted this, therefore is a function. All right.